Let's take a look at the repr method, which is a special method in Python. You can tell that because it's surrounded in double underscores, and it's one of many special methods that are called magic methods. And this is going to be one that produces a string representation of an object when we define it on our classes. Now, that is in the abstract, not a very meaningful thing. Let's take a look at it in specific with a quick example. So I've set up a file, ls46repr, and I've put this in my lessons directory. And you can make this script anywhere. This is just going to be a quick and dirty little demo of the repr magic method. Demo of repr magic method. Okay, so we'll take a look at why it's called a magic method in just a moment. But let's go ahead and set up a class, and we'll use our friend, the point class, the trusty Cartesian coordinate with an x attribute of float that's maybe 0 by default, and a y attribute that's a float that's also 0.0. And I'm just doing this so that we have a simple little class to work with, that we don't need to define a custom constructor. But you'll actually notice that init is a magic method as well, because it's double underscores and you never actually called it specifically yourself. But before we implement repr and take a look at that, let's try just setting up some example code down below. So demo code. And I'm not even going to go to making a main function and using best practices here. We're just going to try and demo the fundamental concept. And first, what's the motivation for even having this at all? Well, let's try setting up a point object. So I'm going to say P0 is a point and it's a new point object, right? And maybe let's change one of these attributes like x, P0.x to be, I don't know, 1.0. Let's get crazy with it. And we'll print P0. Right? And what do we expect will be printed when we run this program? Well, there's no way to know unless you've seen it before, because you could imagine what you want it to be. You really want it to be like 1.0, comma 0.0, maybe surrounded in parentheses. But how would Python even know that that's what you want? We haven't told the programming language how we want the class point to be represented as a string. But let's just try this out and see where we're coming from. So python-m lessons.ls46 repr. And I forgot an R. There we go. Wow, let's see. Okay, so I'm going to ignore this main, but the gist of it is we're thinking about classes that are defined in what our main module was. So our main module that's running is the one that we're executing here. And inside of that, we've got the class point defined. And we see that what we're printing out is P0 is an object. And then this funky looking hexadecimal value is actually its memory address in the Python virtual machine. We're not worried about that at all. We can't do anything meaningful with that, so we're going to ignore it. But what I want you to hopefully realize is that this is pretty unhelpful. The only bit of information that we get out of seeing this string representation is that we know it's a point object we're dealing with. We don't know what its values are. The fact that its memory addresses that really doesn't have any concrete meaning to us, except for really arcane scenarios. So what we'd like this to do is to have like a nicer string representation, that if we want to express this point object as a string, we've got an easy way of doing that. All right, so that's where we're going to enter the magic repr method. All right, so let's try defining this method. So repr is a lot like your ordinary methods. You define it just like a method, but we're going to name it specially underscore repr followed by 2 more underscores. It has a single parameter self. You're not going to have any other parameters defined, and it's going to return a string, right? And the point of this is to return a string representation of the object. Okay. And now what we want to do is exactly that. So we're going to return, and let's use an F string since we've already learned that in an earlier lesson, and they're really handy in scenarios like this. And let's say we wanted to return some parentheses. So parentheses, and then the X attribute, so self.x, comma, self.y. So this is going to produce a string where we have our X value followed by our Y value separated by a comma and then surrounded in parentheses, right? And that's the string that will be returned. So how would we call this method? Well, we would say p0.__repr, and then the parentheses, right? Because this is a method call. And so now self would be P0, and we expect one, parentheses 1, comma 0, end parentheses. So let's just convince ourselves that there's nothing new here yet. There's no magic yet. We're just defining this method as we have been for the past few weeks. So Python m lessons dot ls46 underscore repr. And what do you know? We have this nicer string representation. And right now you're like, Chris, like, this doesn't feel very magical. So what is a magic method? Well, with one quick flick of the wrist, right, we can drop this. And now we can print P0 directly, right? We can print P0. We're saying print this object. We saw what happened when we did this before, right? And what happens when we run this program? And let me be sure that I saved this, right? So I've saved it and I run this again. And what do you know? We get that magic method repr was called without us calling it explicitly. And so the idea of a magic method is one that if you define it on a class, there are going to be certain scenarios where Python calls it for you automagically, right? And this is one of those scenarios. We're trying to print a string to our terminal. So if you have defined a repr method on whatever class that object is an instance of, that method will be called automagically on your behalf. And we could see this in some other scenarios too. Like maybe we make a P1, that's another point, and I won't even change the X of this one. So what if we wanted to print something like the F string of P0 and dash P1? Notice, once again, in both of these conditions, we're just trying to use P1 in the context of a string. And now we run this again and notice that repr is being called in both cases. If we wanted to convince ourselves like that this is actually being evaluated and that this method is actually being called, we could do something you should generally never do. We could try printing a value here. We could say, repr was called, right? If we're going to do this, we may as well do it right, lowercase. And so we would expect, in this scenario, in order for P0 to be converted to a representation that's a string, repr would have needed to be called once, and here it would have needed to be called twice. So we should see that string printed out twice before we see this ultimate F string finally printed out. So I've saved it, and sure enough, there we go. So the idea of a magic method, to reiterate, is there are certain scenarios where magic methods are called, and these are conventional and built into the language, and they're very language dependent. So we've seen this in one other case. You could think of a constructor as a very special magical method that when you called the class name as a function, your constructor definition ultimately was invoked. And similarly, it was defined with these double underscores around it. There are some other examples of actually, there's one more example I want to give you really quickly in terms of when this would actually get called. So let's imagine we had a variable named aster that's a string type, and we called the string constructor on P1, say, and now we print out aster. Right? So in this case, what we're going to see is that when the string constructor gets an object as an argument, it's going to look and see, hey, do you have this repr method defined? And if so, I'm going to call that. And let's just convince ourselves that this works, and 0, 0 gets printed out because we printed P1. So that's another place where when you try and convert an object to a string, when you have this repr method defined, it will automatically be called. So we've seen now two magical methods like this. The constructor is more technically thought of as a constructor, but it's also kind of a magic method. The Python system is invoking that without you having to explicitly. And the reason why it's extra special is you can't really invoke it explicitly. And in here with the repr method, this is going to be called anytime Python wants to convert your object to a string. And this is super handy when you're trying to work in a terminal and print things out and just have string representations of your object. So this is a method that you'll see commonly defined on most classes. There are some other magic methods that we're not going to get to cover in this course, but are really, really cool. They're called operator overloads. And these would give you the ability to, what if you wanted to make it possible to say P0 plus, like what if we wanted to be able to say P2 is P0 plus P1? Well, if we had defined a magic method, and if you go and look in the Python reference about your operator overload methods, you could try this out. You could define what happens in this case. And there are going to be some libraries you encounter if you continue working in Python, especially if you go into the field of data science and look at the pandas library, but many others as well, where people meaningfully use operator overloads. And this can be a little bit confusing at first, because what does it even mean to add one point object to another? Well, the magic methods in operator overloads can be used to define that. Again, that's outside of the scope of this, but just a hint that behind the scenes, there would be a method called in this case that would allow you to implement this kind of logic if you really wanted to. For our purposes, knowing the constructor, of course, and as well as this special magic repr method is enough to cover most cases in the early introductory object-oriented experiences that you'll have learning how to program.